All right, number 16. Again, here's another classic one from Math 20. We've got this rectangular open top box. We're going to make it from a piece of cardboard or whatever it is by just cutting out the corners. So we're going to cut little squares out of the corners here, and then we're going to fold it up. Each of these is going to be X by X, but here's the trick. This is 18 wide and this is 48 long. Now if you think back to Math 20, the restriction that we had on here was the value of X, okay, had to be bigger than 0 because we are cutting something out of that piece of paper or piece of cardboard, okay, but it has to be less than 9. What I'm doing here is I'm looking at the smaller number here, the width, and I'm taking half of it. If the largest X can be is half of the width, because at that point here, if you go, even if you go up to 9, all you're doing is you're not cutting out a corner, you're cutting a large chunk out of this because your X's are covering the entire half of this thing. And it cuts it right out, so you can't do that. Okay. So from here though, I can see that my volume is going to be 48 minus 2 x's. That's how long the box is going to be. And then x here and x here, take it out. 18 minus 2x, that's the width. Okay, 18 across, but I'm taking 2 x's out. And then the height is going to be x. Now, in the interest of time here, I'm just going to jump ahead here. When I expand this out, you're going to get 4x cubed minus 132x squared plus 864x. Okay, those are kind of nasty big numbers, but I have a feeling that'll simplify real quick, because what we're going to do here is take the derivative, and it turns out the derivative is 12x squared minus 264x plus 864. I'm going to set that equal to 0 to maximize it. Whoops, 264x plus 864. And the beautiful thing is everything there is divisible by 12. Okay, which is huge. And that makes this very easy to factor. The factors of 72 that are going to sum up to 22 will end up being negative 18 and negative 4, which means my values are 18 and 4. But you got to consider the restriction here. 18 is no good. This has got to be just the value 4. So when the size of the square here is 4, I know that what's going on here is I'm getting a maximum volume. Now I can check that as well here, because if you take the original cubic here, the cubic is going to have roots that look like this. Okay, it's going to have a root here at 0. Okay, it's going to have a root here at 9, and also a root here at 24. As soon as when this thing dips down here, the reason why it's going down is because the width ends up doing something weird. The width ends up being negative as the length stays positive. So you're getting this weird kind of a negative area here. So none of this makes any sense. And there is the natural maximum that we're getting at 4.